They are very important things because they provide a fantastic curios in the later time of history. In fact, sundials, especially the portable sundials, they were more accurate they were more accurate than watches in telling the time up to mid-18th century. That was the peak of sundial trades.
Someone check the stream.
To the right most, you can see that that's a ring dial. Basically, you can just wear it on your finger, and it was pretty accurate in telling the time of the day. Yes. And slightly to the left of it, you see, oh, that's the sundial they sell it to the Muslims. Because not only can you tell the time of the day for their prayers, but it also tells them the direction of Mecca. Because a magnetic needle was attached to it, so it served like a compass. Kind of. Yeah. And of course, the trade of sundials, it worked really well. Oh, that's the only one to highlight. That's the universal to the leftmost. There's a universal equinoctial ring dial. It's a sundial that works on raining days. Yeah, so that is really kind of counterintuition. It works that basically, right, you have used the celestial navigation knowledge. So you point up to the eye level and then try to find the horizon, and there was some kind of I can refer to this. If we have time, maybe I can tell you more about this after I finish the talk, because I actually done some research on it and it was quite interesting to me. Apart from sundials, another part that humans have made a lot of wide applications in astronomical knowledge is actually celestial navigation.
Yeah,
so
they asked us to play closer.
In Spain, in the era of discovery, cosmography, or the study of the shape of the universe and the world, to them that was the world back then, it was a state secret. Maybe because that, prior to navigation as a science, right, most of the ships and the vessels can only travel along the coastline because it's extremely difficult to identify where you are on Earth before you're able to scientifically navigate your location on the Earth. So the only way to make sure that you are traveling along the right direction is that you stick to the coastline and you don't go too far. And of course, that's quite restricting because after a while you don't have much place to explore and you're just restricted to the continent. However, navigation brought change to that, and especially the use of astronomical equipment. How should I put it? For instance, I think the one that that's the Mariner's astrolabe. So basically, it's the use of to observe the sun, the position of the sun in the sky, or maybe one of the particular stars, as well as to determine its distance from the horizon, to find out where you are. Or you could have a star chart, that keeps track of how should I put it? That's called dead reckoning actually. The number of days that you have left the port and the direction that you are going. That's basically the job of the mariner or the ship captain to determine where the ship is. And that eventually brought to the discovery of the New World. Okay, I think that was very important because a lot of things seem quite dry just now. I really have to brought them in because they were very important in our later slides when we come into the regional studies of astronomy in the ancient world in the different regions of the continents or different continents. The first question to answer is, was there a timeline kind of, to the development of astronomical discoveries? And could there be a timeline? I mean, timeline only exists when there is breakthroughs and when there is communication across the civilizations. Another part is that the regional applications and the focus of astronomical knowledge actually kind of diversified because they have different cultural specific regions. So let's begin there with two fun facts. The first is what I mentioned to you earlier, that's the peace treaty from an eclipse. So the Battle of the Eclipse was fought between the Medes and the Lydians in 585 BC on 20th of May. We are able to have this date because we are able to calculate when the day that the solar eclipse actually occurred. So the result was a draw, which led to both parties negotiating a peace treaty and ending the 6-year war. According to Herodotus, which was a historian, the appearance of a solar eclipse at the time of the battle was interpreted as an omen and interrupted the battle. Herodotus also mentioned that the laws of daylight had been predicted by Thales of Miletus. So that resulted in the peace of decades until both were conquered by the Persian Empire that rose later, but that was still about 500 years BC. So the thing is, how did tailors know that a solar eclipse will occur on that day? Oh, by the way, let me just show you the map. You can see here that that's the Median Empire, to the rightmost. This is actually modern day Turkey. So the sea on top there, that's the Black Sea, and that's the Lydian Empire. The river that they had a battle, that was called the Halis River. And Palace of Miletus is actually, it's one of the small islands to the left of Lydian. It's actually a Greek city-state. I know, that's Miletus. The other fact I want to share is actually this Gobekli. It's actually the world's first temple. It dated back to 10 or 8 millennium BC. That's basically close to 8,000 years BC, predating the Stonehenge by 6,000 years. It's located in southern Turkey, so that's actually very similar to just now, where we've seen. It's approximately the same area, and that's the Mesopotamia area. It's built to worship the dog star, Sirius, or by who? A possible explanation is that it was built by maybe the ancient Egyptians, because the hierarchical rising of Sirius each year in mid-August was the signal for the annual flooding of River Nile. And you know that because of the floodplain, the agriculture, they have to know very well the annual flooding seasons of the river. And so that was the ancient Egyptian name of the star Sirius. So as I've seen, Babylonian astrology and the zodiac. We've seen in the map just now that Babylonian Empire was actually about the center of the world. Then, you had interaction with the Median and the Lydian as well as the Egyptian empires. Babylonian astrology was an electional astrology, also known as event astrology. Basically, that's the idea that they use whatever they observe in the night sky to plan for events that they want to hold. They view the celestial events as signs rather than the causes of physical events. The oldest architecture discovery we had was the Venus table of Anisadoka. It's thought to be compiled in Babylon around 1700 BC. It's the record of astronomical observations of Venus. For instance, the first and last visibility above the horizon for 21 years. Yeah, during that time. It is a part of a longer text of Babylonian astrology. We're looking at Mesopotamian astrology because that's the location of it. It has some parallels with Hellenistic or Greek astrology, including the zodiac, because although it may not be a mystery, because we don't have enough historical records of what they were doing. But basically, we can say that Babylonian astrology was the first organized social-wide, we can think it as a systematic astrology that existed. Oh, okay, that's interesting. Okay, I want to bring your attention to the Egyptian city of Alexandria. When we think about Egypt, the first thing that came to us is usually the pyramids, or maybe the city of Cairo and, pyramids and, the everlasting Egyptian wonders, the architecture. But actually, the city of Alexandria was very interesting because first and foremost, the city it was founded by Alexander the Great, who was a king. Actually, it's a king of the Greek Empire, the ancient Greek. Yeah, I know, that's right. It became the place where the Babylonian astrology was mixed with Egyptian decanic astrology to create horoscopic astrology. Decanic, as you divide the zodiac into 36 decans of 10 degrees each. So basically, right, how should I put it is that Alexandria. Okay, let me just bring attention to the picture on the top right corner. That was a depiction of the burning of the Great Library of Alexandria. That was known to be one of the ancient wonders in human history. And so you can see that is actually the beginning of, we are seeing how Babylonian astrology were becoming useful to, it contributed to the more modern interpretations of astrology. So the astrologer and astronomer Ptolemy, they actually lived in Alexandria, whose work was actually forming the basis of Western astrology. And he also created a geocentric model of the universe, which was only challenged until much later times, when we had developed the telescope. Okay, let's move on to Islamic cosmology. The Islamic cosmology was actually encouraged by the holy book, the Quran, because the Quran actually encouraged the medieval time Muslims to pursue the scientific endeavors, because the way they put it is that the glory of the Creator, the God, is revealed in His creations. So he also encouraged the Muslims to use the stars and the moon for guidance, especially in their daily prayers or in their pilgrimage, the one that they have to travel to the holy city of Mecca, around the building of Kaaba. They are the successors of Hellenistic astronomical knowledge, and also they invented new instruments and developed new theories. The most important person in the concept of Islamic cosmology was Al-Khwarizmi and his LCD, which was approximately 37 chapters on astronomical calculations and his tables of astronomical and astrological data. He was deemed to be a great astronomer as well as mathematician, and a scientist, of course. It is the first of many Arabic ziyas, I can't pronounce that word, I hope that's how it's pronounced, based on the Indian astronomical methods known as the Sindhi. The work also contains tables for the movement of the sun, the moon, and the 5 planets known at that time. And also the Muslims has used much celestial navigation to tell the sacred directions, or to decide their 5 prayers. Another interesting concept about the Islamic astronomy is actually the difference between folk astronomy and mathematical astronomy. Because prior to Islamic faith, there were people living on the Arabian Peninsula. They are the Arabs. Sorry, I can't pronounce. Before the Islamic, they had some primitive observations of the night sky, and there's some knowledge of simple celestial navigation. So all this knowledge they are preserved as folk astronomy even until today, which is, for instance, it's just using your bare eye to observe the moon or trying to use simple calculation of the moon phase to determine the dates. However, the Muslim astronomers brought rigorous discipline to the stargazing activities, and they produced an enormous collection of scientific literature from cosmology to computational techniques. The Muslim scientists did not have a wide audience, since the solutions that they proposed to a lot of the religious rituals were generally considered to be too complicated or even irrelevant to the common folks. So for instance, one thing is that the medieval books, they were invariably not oriented properly towards the Mecca. Think about the United States. If you're in the United States, you're actually literally on the opposite side of the earth. And it's very difficult for you to just use your folk astronomy without any thinking, back then you could think that the world is flat, so you could easily find the direction of Mecca from anywhere on the earth. But if the earth is round and you're in the United States, how do you decide where the holy city really is? By right, your mosque should be built in such a way that it should face the holy city of Mecca. Also, there was much confusion about the determination of the Ramadan, which is the month that, in Singapore we celebrate it as the Hari Raya. It's difficult because the beginning and the end of the month was determined by a moon sighting committee in Saudi Arabia. It begins, which was a practice that been holding ever since the time of Prophet Muhammad. It begins the day after the committee spots the new crescent moon with their bare eyes, which can be very tricky since it's quite faint and can only be seen for about 30 minutes. If the moon isn't visible due to haze or clouds, then they have to use the lunar calculation to predict whether it's in the sky. So that actually every year it created some confusions to which is the right day to start the Ramadan. And they are unwilling to accept the suggestions by the scientists. And basically that's the issue between the folk astronomy and the mathematical astronomy. Folk astronomy, however, it became quite an important thing in the Maya astronomy and their famous calendars. Because the thing is that the pre-Columbian Maya civilization, they developed a very accurate pre-telescope astronomy in the world. It's like they just use their bare eyes to observe the night sky, and as well as to develop the calendars and in their own writing system and in their own mathematics knowledge, which were fully indigenous to the Mesoamerica. The most famous feature of the Maya astronomy is, of course, as we know, the three Maya calendars. But the Ha'ab is basically a solar calendar. It's a 365-day year made up of 18 months and 20 days each, plus a period of 5 days, which are called the nameless or the unlucky days, at the end of a year, which is known as YIH. The Dzogchen is a kind of, okay, let's put it this way. The Ha'ab, right, is a very solar, it is a very common calendar because it simply observes the change in the seasons and as well as the motion of the Earth around the sun. So that's actually quite similar to what we have today. That's the solar calendar. But Dzogchen is a total, it is a very religious calendar. It doesn't really follow the natural motion of the astronomy. It's like, it consists of 260 days that combines 20 day names, it's like 20 different names, with 13 day numbers to produce 260 unique days. Unique as in, it's like they assign a name of a god to each of the 260 days. And as the most sacred calendar, it was used as an almanac to determine the farming cycles, as well as to specify the dates for religious ceremonies. For example, they think that this could be the day of some god, they think that that's the birthday of this god, and they will perform the ceremonies on this specific day. Last but not least, there's the long count calendar, which is just a count of days. It only consists of days, which identifies a date by counting the number of days from the so-called, that's what they believe, the Mayan creation date. We believe that to be August 11, 3000 years BC, in the Gregorian calendar. Instead of a base 10 scheme, they use a base 20 scheme. So for example, as you can see there, 00015 is actually 25 days. So 25 days since 00000. Okay? The issue with that is, why so long? What is the point of adopting such a long count calendar? Let's just do something that's called a calendar round date. It is a date when the Dzogchen and the Ha'ab coincide, because 260 and 365. They will coincide after every 52 half years, or 18,980 days. And that's known as a calendar round. But in order to specify dates over periods longer than 52 years, they have to use a long count calendar. Some of the misinterpretations include that, it was the end of the world on December 21, 2012, which was simply the day that the calendar went to the next platoon at long count 130000. Okay, let me just put some notes here. You can see that one kin is like 1 day in the half calendar, and 20 kins, basically that's the moving up to the next digit. There is 1 dinar and 1 tun, 1 katun, 1 batun. Usually we only use up to batun, and pictun was very, very rarely seen in literature. So the date of the start of the next platoon is actually March 26. There's 2407, that's about 400 years later. The date of the start of the next platoon was about 2000 years later. But that doesn't answer our question, as in why do we need to have super long units of time in the calendar itself? A possible explanation to that is actually the discourse of power analysis. Wait, did I cover that just now? I hope so. So basically, right, this is a concept that there's power shown in communication. It shows the level of power in a society. So, is there any Buddhists here in this room? No one? Okay, never mind. You know that in Buddhism, right, the Buddha used very strange time units that is not commonly known to the common folks. For example, the Buddha will talk about, one kasana. Kasana is about 1 million times of, it's a very small time unit. There is about 1/1 million of a second. Yeah, and they will use much larger units that is like consisting of 4.32 billion Earth years. That's a kalpa, right?
I guess kalpa.
Yes, a kalpa. There's 4.32 billion Earth years, and the Buddha will just use that to to describe a certain teaching of his. And it's very interesting, why would they turn to such long time units? A possible explanation is that it shows the difference in perception of the world between those who are common, those who are the commoners, as well as those who are the priests or those who are closer to God. It shows that they are able to live for so long, or they're able to, they are just fundamentally different perception of time with you people. So it shows a hierarchy in power in a society. I mean, that's just a possible explanation that we have here. Let's move on. Oh, okay, the Chinese. That was important because discourse of power analysis was actually much more prevalent in the Chinese studies of astronomy. The Chinese, they will actually deal as astronomical knowledge as culture. Culture is here, okay, guys, silence please. I mean, when we talk about it, culture. What is culture to you guys? Culture? When we say that someone is cultured? No response. Okay, fine. I mean, culture, in this context here, refers to a way of living. For instance, the arts and literature, they refer to describe how people are supposed to live, or the ideal perceptions of life, of beauty. They have seen that in the poetry such as 人生不相见，动如参与商. It simply translates to, we do not meet each other in life, just like the Orion and the Scorpios. And the myths. 一个一水间，默默不得已. That's referring to the summer triangle that only appears around the 7th month of the lunar calendar. As well as the farmer's almanac, that's the Huangli that I referred to just now. It gives you a lot of feng shui knowledge, as well as the lucky days and the auspiciousness of the date itself, of what they should do. It's related to Confucianism and Li. Li is the practice of following the specific time of the year to do certain things. For instance, the heaven-man interaction, that's concerning the emperor and the ruling class. How about, for example, if they observe something that is abnormal in the night sky, then that means they have done something wrong that angers the god. So they should change the name of the year, and that's Bai Yuan. That's not what I have said that. As well as, it also concerns the normal people, because there is also a periodic social practice. For instance, every year we are able to determine the date of the Chinese New Year, and you're supposed to do certain things on Chinese New Year. So calendar is one way for, the right timing is for them to determine the time of the year to do certain things, and they are supposed to do it. The mid-autumn you're supposed to do certain things, and Qingming you're supposed to do certain things. Next up, I also talk about the Taoism and Chinese astrology, as well as the measurements of heaven. How do they conduct the astronomical observations, as well as recording it. Okay, Taoism and Chinese astrology. Oh, I borrowed this interpretation from one of our members here, as Grace. The ancient Chinese astronomers divided the night sky into 5 great regions called the Gong, or the palaces, equating them to the directions north, south, east, and west, and the central region. And each region is associated with a mystic animal and the color of it. So there's the dragon, the phoenix, the tiger, and tortoise. I think it's tortoise. Yeah. And Taoism is a polytheistic religion. That means it's a religion of many gods. So they're grouping of stars into the 28 mansions, and 365 star officers are important in their belief that, through the observation of certain, the movement of certain stars and planets, you are able to interpret the meaning, or the divine revelation, or the oracle of the god, whatever the message the god is trying to send to you through the movement of the star itself. Also, astronomy is important in the feng shui navigation and in some of the fortune telling activities, for instance, the Zhirong Doshu. But that's not very interesting, because the most interesting thing to me about the Chinese astronomy is actually how they measure the night sky. There's 2 parts to it. There's the observation and measurement. The observation of the night sky, as well as just astronomical objects, is actually quite mathematical for the Chinese aspect. So they have seen this book called 周必算经, which is the oldest Chinese mathematical text. Zhou refers to the Zhou dynasty, and that was about 1,000 years BC to 200 years BC. Well, P refers to the gnomon. It's like the projecting piece that shows the time, like the position of shadow on the sundial. You know, it's like the edge thing, the standing piece of it. And scientists were like such as Zhang Pen, and who created an armillary sphere is called Wen Tianyi, who catalogs 2,500 stars, which he placed in the bright shining category. The Chinese estimate that to be 14,000 stars altogether of the night sky. He recognized 124 constellations. Oh, let me just show you the picture. There's a picture that I got from the book itself, the Zhou Bi Shan Jing. Basically, it's a picture to calculate the height of the sun, or the distance of the sun from the earth. So you're able to, you know, just have two poles with some distance between each other, and by calculating the distance of the height of the pole as well as the distance of it, and some trigonometry knowledge, you're able to find the height of the sun. But all of these are belonging to a time when the China civilization did not really have much interaction with the Western astronomy. Things changed a lot when they embraced the Western astronomy since the late Ming Dynasty. Historical record is another feature of how the Chinese conduct their astronomy, because they had a lot of emphasis on it is important to record down whatever they had known about astronomy or the observations they had as part of the historical records of whatever is happening in the year. Talking about how the Chinese embrace the Western astronomy, we must give some attention to Jesuit education and their observatories. Okay, I'm not sure if you heard this, but there's a Society of Jesus that was founded in 1514. Yeah, it is how should I put it? It is a society that, okay, first and foremost, fundamentally it is a religious society, but they have a lot of focus on conducting education as well as astronomical observations and mathematical research. In the 18th century, the Jesuit observatories in Europe made up about a quarter of all the existing observatories, where they will conduct works in astronomy and meteorological observations. Some of the reasons for their scientific works and the foundation of the observatories, why they put so much money into it, is because they have a tradition of apostolic spirituality. It's like they encourage an active engagement with the world, and there's a sanctification of learning. It's like learning is sacred, kind of. Find God in all things is used by the co-founder of the society itself, referring to a Jesuit attitude in the active life of education and missionary. Why do I mention that is because I have some picture here that unfortunately you all can't see. On the leftmost, that is the guy called Tang Ruowang, right? I think so. That's how he preferred to be referred to in his Chinese name. He was the guy who came to late Ming China, and very quickly he became the director of the Chinese Royal Astronomy. And after him, almost every director of the Royal Astronomy in Beijing, in Imperial China, were foreigners, and they were mostly Jesuit missionaries. It's interesting. Here is the list of all the observatories that the Jesuit Society had founded for a period of 200 years. And you can see that it's basically in every continent, North America, Europe, China, and yes, Africa, everywhere. So it's pretty interesting because they had contributed a lot to modern astronomy. And it's like they're the bridge between what we call the ancient astronomy and the modern astronomy. Okay, early European explorers. Okay, we all know that the Industrial Revolution happened in Europe, and it basically, that really brought a lot of changes to the society in every aspect of society, including how we conduct scientific observations of the night sky. But before that, the native Europeans, they also had some kind of, it's very natural for them to look up to the night sky and to observe certain patterns. So for instance, we see there's a Stonehenge, which is one of the opening is actually aligned to the sunset of the winter solstice and opposing sunrise of the summer solstice. But the purpose of it we do not know because I've lost track of. any historical accounts or records of that, which we can show that it's quite important. I mean, that's why that in earlier examples, we've seen how the China and we're able to have some, records of what they were doing with that. The Viking mariners from late 8th to late 11th century was actually, they applied astronomical knowledge in their trades and warfares. So basically, that's a part of the celestial navigation, with the astrolabe and other instruments. They applied astronomical knowledge, for example, knowing that it is possible to circumnavigate the Earth, that means to travel around the Earth, and that all of those, they add up to contribute to the discovery of the New World. And I think that's essentially the last slide of me on ancient astronomy. So that's the end of it. In Wei Zhong's talk in week 7, he will cover more on the history of modern astronomy, with a focus on the scientific revolutions and the usage of telescopes and how that make a difference. Okay? So sorry to have you all guys so bored for the past 30 minutes or so. Yeah.
Okay, no worries. Okay. Now it's free food.
Someone own the light, please. I didn't know it's that hard to talk in the mask.
Yeah. But we'll solid last for 1 hour.
Is it 1 hour?
No, I thought it was 45 minutes.
No.